Hi everybody. So the next unit we're going to look at is 6.2, and this is on simplifying expressions using the laws of exponents. So you want to use the laws of exponents to simplify expressions involving fractional or rational exponents, like we talked about yesterday, and we'll talk about what these laws of exponents are. You probably know some of these already anyway. And then we'll use these laws of exponents to simplify radical expressions. So again, that's expressions with square roots and things in them, but they may not necessarily be in the exponent. And then we'll talk about factoring exponents containing rational exponents or fractional exponents out. So let me just first of all remind you about what an exponent is. So an exponent, again, is something where you're taking a number multiplied times itself several times. This number up here is called the exponent or power, and this number is called the base. So, for example, if you have, say, 7 to the third power, that just means 7 times 7 times 7. So don't forget what that notation really means. So some examples would be like if you have 3 squared, right, that would be 9. 2 to the 5th, that would be 5 times its, or 2 times itself 5 times. So that would be 2 times another 2, which is 4, times another 2, which is 8, times another 2, which would be 16, times the 5th 2, which would be 32, right? So in other words, you'll have 2 times 2 times 2 times 2 times 2, which will just give you 2 to the 5th, or 32. Right? This would just mean that you're taking x times itself 7 times. So that brings us to what's known as the rules, or sometimes called the laws of exponents. And so, again, these are rules that you might already know, but let me talk about what they mean here. So the first rule says basically that if you multiply something with the same base times itself raised to a power, then you add the power. So for example, if you have 2 to the third times 2 to the 5th, if you think about what that really means, that means 2 times 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 2, right? Because you're taking 2 to the third times 2 to the 5th. How many 2's are you multiplying all together there? Well, you're multiplying 8. So basically, the shortcut for that is just adding the exponents, right? Imagine you had 2 to the 100th times 2 to the 300th, right? I wouldn't want to write it out this way. You could just write it as 2 to the 400th. Right, the second rule says that if you raise a power to a power, then you multiply the exponents. An example of this would be something where you have 2 to the third to the 5th. Again, that would just be 2 to the 15th, right? Because if you think about this, it just means you're taking 2 to the third times itself 5 times, so you would just multiply the exponents. And then lastly, if you have two things multiplied together, and I should mention that this might apply to more than two things. So let's say you have x plus, or x times y times z to the nth power. That would also work, so it doesn't have to be just two things. But if you raise things that are multiplied together raised to a power, you can apply that power to each thing separately. Right? So for example, if you have 3 times x squared, you can just write that as 3 squared times x squared. Now, one thing to warn you about is that does not work for addition, right, or subtraction. If you have like x plus 3 squared, remember that will give you x squared plus 6x plus 9, not just x squared plus 9. So just watch out for that. Now there are some other laws of exponents here that we'll talk about, but we'll maybe talk about these more in the next section. But one is, there's just like we have a law for multiplying exponents here, we also have a law for dividing exponents. And I guess this should say other laws, not. But so, for example, if you have the same base here where you're dividing, right, you subtract the exponents, and this only works if the base is the same. So if this was a and this was b, you can't do that. But as an example, let's say you have 2 to the 5th divided by 2 to the 3rd. If you think about what that really means, that means 2 times 2 times 2 times 2 times 2 divided by 2 times 2 times 2. Each one of these 2's will cancel with a 2 on the top, leaving you with just 2 squared, right? Because remember, anything divided by itself is just 1, and you can only divide this 2 in the bottom into one of the 2's on top. So those will all cancel and give you 1. You'll get 2 squared. So more generally, right, if you had something like, let's say you had 2 to the 500 power divided by 2 to the 300 power, right? I certainly wouldn't want to write it out this way because that would take forever, but or a long time anyway. But again, you can just use the rules and write that as 2 to the 200. Right? You can also write it this way also, especially if you have like negative exponents. So let's say that you have 2 to the 500 over 2 to the 700. Right? If you use that rule, that would be the same thing as 2 to the 500 minus 700, which would give you that to the negative 200. So you could also write that as 1 over 2 to the 200 power, right? Because if you have negative exponents, you can move things from the top to the bottom. Another law that you might see, which is a sort of a combination of laws, is this one. If you have a fraction raised to a negative power, you can just flip the fraction upside down and change it to another power. So let's say you have 2/3 raised to the negative 5. You can just automatically write that as 3/2 to the positive 5. You can also sort of use it in reverse, right? If you have, say, 7/5 to the 3rd power, you can write that as 5/7 to the negative 3 power. So as far as simplifying expressions with exponents, so let's say you wanted to simplify something like this or more complicated, how do you do that? What are the steps? So overall, the steps are to combine the variables and constants using the rules we just talked about, so that you have one variable of each type appear in your expression at most once, and it's raised to a single number. So that would mean you basically want to kind of combine all, if you're, let's say you have x in the expression, you want to combine all your x's together so that you just get x raised to one number, like maybe x to the 3rd or whatever. And then you'd want to do the same thing with your y's and your z's or whatever things you have in there. And then you want to rearrange the expression so that all the exponents are positive. So maybe just to break this down a little bit more, so to simplify an expression, right, with exponents or radicals in it, is all exponents should be positive. Each base, so each x, y, or z, or whatever variable you have, should appear once. There are no parentheses in the expression, so you don't want anything, again, where you have like x to the 3rd to the 5th, because you can simplify that as x to the 15th, for example. You can just multiply the exponents. And there are no powers written to powers, which I guess would be another way of saying that. But yeah, and I guess you don't want any parentheses either. So some examples would be like, let's say you've got 9 to the 1/4 times 9 to the 1/3. So because the bases are the same, you would just add the exponents together. Now in this case it's a little bit tricky because you have fractions, but the common denominator would be 12. So 1/4 would become 3/12, and 1/3 would become 4/12. That would give you 9 to the 7/12. And then you're done, right? That exponent's positive. There's just one base. There are no parentheses and no powers written to powers. So that would be simplified. For something like this, again, you'd want to subtract the exponents. So take 1/5 minus 9/2, which will give you y to the negative 7/10. And then, again, you don't want negative exponents, so just use one of the previous rules we saw to move that to the bottom of the expression. So here's some other examples. So here you have a power raised to a power. So multiply them together, you get a negative, so just move that to the bottom. Right? For this one, again, you would just add the exponents. So negative 4/9 plus 1/9 will give you, I guess, negative 3/9 over here. And then you've got this expression. If you add these together, that'll give you 14/9. And then, again, you want positive exponents only, so move that to the bottom. Now, the coefficients can be negative, so that's okay. But that would simplify that expression. Here's another example where you have parentheses. So because you have a power raised to a power, you can take this and multiply it times each exponent separately, including the 25. So you'd have 25 to the 1/2, which is really just the same thing as the square root of 25, so that'll just be 5. Then you'll have x to the 2/5 times 1/2, so that would be x to the 1/5 if you reduce it. And then you'll have that times y to the negative 1/2, but again, that you want to move to the bottom. So you would write the expression that way and then just try to reduce all the fractions. But you've got 1x raised to a power, 1y raised to a power, and there are no parentheses or powers raised to powers. As far as simplifying the following, you you know what you'd want to do in this case is, let's say you've got the cube root of a to the 6. You could just simply, and sorry, this should be down on the same level as everything else. So this looks like an exponent, but it's not. So remember, we saw from previous sections that in this case, you would write this as a to the 6 divided by 3, which would just be a squared. Now, let's say you want to simplify this, right? We saw in the last section you can write that as w to the 2/3 and w to the 1/2, and then just subtract the exponents and then just reduce there. Or something like this, you can apply the 1/2 to each thing separately. So you'd get 64 to the 1/2, a to the 1/2 times 1/2, which would give a to the 1/4. There's an implied 1 here, so 1 times a half is a half. A to the -2 times a half will give you -1. And then b to the 4/3 times 1/2 will give you b to the 4/6, or 2/3 if you reduce. And then again, just make sure all the exponents are positive. You can take a to the 1/4 times a. So if you move this up to the top, that'll become a to the +1. Then just add the exponents here. So the square root of 64 is 8. 1/4 plus 1 is 5/4. And then there's really nothing to do with the b here, right? You should just be able to reduce that. But maybe just show you where this is coming from here, right? You'll basically have b to the, this will be to the 2/3, and it'll be minus 1/2 there, right? So if you take that and write that as b to the 2/3 minus 2/4, or I'm sorry, the common denominator would be 6, right? So I guess when I multiply here by 4, top and the bottom here, sorry, by 3, right? You'll get 4/6 minus 3/6, which will give you 1/6, and that gives you your final answer, right? You'll notice here that I've just got 1a raised to a power, 1b raised to a power, so I've combined all my a's and my b's together, and then there are no parentheses or powers, 2 powers. Okay, so let's look at some other examples here where I haven't worked these out yet. So, and again, you don't have to explicitly show every step for these, but so basically I've got all this stuff raised to this power, so that's going to be giving me -2 to the 3rd times x to the 3rd times y to the 2 to the 3rd, so that'll give me y to the 6. So again, you just multiply the exponents together. Remember, there's an implied 1 there and an implied 1 in the -2. Same thing for this one, right? This will give you 3 to the 5th times x to the 15th times y to the 5th. Then you just need to combine terms together. So I've got 3 to the 5th, right? I don't know what that is. I guess that'd be what, 81 times 3, so that'd be what, 243. So I'll have -8 times 243, which we can simplify in a minute. So I'm just going to move the constants next to each other. And then what's x to the 3rd times x to the 15th? Well, again, when you're multiplying, you add exponents, so that'll give me x to the 18th. And then for the y, I'll get 6 plus 5, which would give me 11. And then, that's basically your answer. Maybe just to simplify the number there, right? If you take 8 times 243, that'll give you 1944. So this will be like -1944 times x to the 18th, y to the 11th, right? And that's as simplified as we can go because the exponents are all positive. I've got 1x raised to a power, 1y raised to a power. It's okay if the coefficient is negative, just as long as the exponents aren't. Now for this one, you got to be a little bit careful, right? Here I'm just multiplying everything together. I'm taking 3 times x cubed times y. Same thing over here. But here I've got the subtraction sign. You might think that that means that I'm multiplying by -x, but unless you have parentheses around there, it's assumed that you're subtracting. So the one thing you got to worry about for this one is, because I'm adding or subtracting in here, I can't quite do what I did for the one before. I can't just take the 2 and put it down on each thing separately, right? What you'd really want to do is just rewrite this as xy cubed minus x times xy cubed minus x, and then FOIL it out. So just watch out for that. So if I FOIL that out, I'll get the first term here times the first term here. So that times that will give me xy to the 6, because remember, I add the exponents when I'm multiplying, so it's just x times x, which, oh sorry, that should be x squared, and then y cubed times y cubed would give me y to the 3 plus 3, or 6. Then take this times that, so I'll get -x squared y cubed, but then I'm going to get another one from that, so I can just double that. I'll add those together. And then finally, I just take x times x, or negative x times negative x, which would give me positive x squared. And then that's all the further I can go, right? Remember, when you're adding and subtracting expressions like this, you can only combine them together if they have the exact same base and the same power. So you can't add this to that or that to that, right? It's like they're not like terms, right? So it's like you've got, an apple, negative 2 oranges, and pear or something, right? You can't add apples and oranges together. Now, we already kind of looked at this rule already, but maybe just to talk about this rule in a little bit more detail, right? This rule basically says that, again, if you're dividing, you just subtract the exponents. Right? So let's maybe come back and look at this rule in a little bit more detail here. So again, for something like this, it's pretty simple, right? You would just subtract the exponents and get 3 here, right? Now, for something like this, right, you'd want to simplify this considerably before you apply that rule. Again, you could apply the 3 on each thing separately because I'm just multiplying, so I'll get 2 to the 3rd times x to the 12th times y to the 6th. And then on the bottom, I'm just going to leave the 2x squared alone for now. And then here I would take it times 3 squared times x squared y squared, right? Then you got to combine all your x's and y's together. So let's just do that on the top and the bottom first here. So 2 cubed, that's 8. Then I'll get x to the 12th, y to the 6th. There are no other things to combine on the top. Now on the bottom here, I've got a negative 2, and then I've got x squared times x squared, which will give me x to the 4th. And that's the only other thing I have. I've got a y on the bottom there, and then I guess I do have a 3 squared, which would be 9. I guess maybe I should have moved that next to the 2, but we'll do that in the next step, right? So you'll get 8 times x to the 12th, y to the 6th, divided by negative 2 times 9 is negative 18, and then I'll have x to the 4th, y squared, and then I can start reducing, right? So 2 goes into both 8 and 18, and it'll go into 8 4 times and 18 9 times, and then I can just reduce here, right? So x to the 12th divided by x to the 4th is just x to the 8th. You can just do this a variable at a time, and then here I'll get y to the 4th, and then that's your final answer, right? I guess you can kind of move that negative wherever you want, but that should be your final answer for that one, right? And again, if you look at it, it is simplified, right? I've got 1x raised to a power. I've combined all my x's together. I've combined all my y's together, and the exponents, neither exponent is negative, right? Now the coefficient's negative, but that's okay, right? For something like this, again, you would just reduce this part. So 9 divided by 3 is 3, and then just subtract the exponents. That'll give you x to the 3rd. For something more complicated, again, like this one, let me maybe do this one a little bit more quickly. Here you would just get 3 cubed, which would be 27. You get a to the 6th, and then that would be times a to the 5th, y to the 10th, all divided by 15a squared y, right? So you can reduce the 27 and the 15, right, because 3 goes into both of them. That'll give you 9 over 5. And then just do the same thing with the a's here, right? You'll get a to the 6th times a to the 5th, which is a to the 11th, divided by a to the 2nd. So you'll get a to the 11th. You'll get 11 minus 2, so that'd be a to the 9th. And then for the y's, you just have y to the 9th, because that one's going to cancel with that on the bottom there. And be careful with these, because your a's can look an awful lot like 9s. And then that's your final answer, right? I've got 1a raised to a power, 1y raised to a power. The exponents are positive. So that's what you'd kind of want to do with those. Now, there are some other rules of exponents also that we've kind of looked at. This is sort of the analog for, remember when we had x times y to the nth power. Remember, we could apply that power to each thing separately. Well, it turns out you can also do that if you're dividing. So here's some examples here. I don't know if this will hopefully not be that complicated. But again, according to this rule, if I've got a fraction raised to a power, I can just apply that power in each thing separately. And you can do this a step at a time if you want. You could actually apply this to the top and the bottom. You could write this as 2xy squared cubed, and then write this as that cubed. But I'm just going to kind of skip that step and just apply the 3 to each thing separately. So that'll give me 8, right? So remember, don't multiply these together accidentally, right? It's not 2 times 3 is 8, right? It's 3 times the power, which would be 2 cubed, or 8. And then I'll have x to the third times y to the 6th divided by 4 to the third power, right, which is 64, times x to the 6 times y cubed, and then just reduce each thing, right? So 8 goes into 64 8 times. Here I'll just get an x to the third in the bottom, because I'll take 6 minus 3. And then finally I'll get y to the third. And again, none of the exponents are negative, so that's simplified, right? For something like this, I guess we're not quite using the same rule, but one thing to warn you about is you can only combine things like this together if the exponents are the same. So if this was 3 and that was 3, for example, you could write that as x squared times y over xy, that whole thing to the third power. But because they're different, we would just apply the rules that we had before. So this would just be x to the 6th, y to the third. That would be over x to the 5th, y to the 5th. And so that would just give you x over y squared, and that would be the simplified version of the answer. A couple other rules to remember, which you might have had before, is that if you have 0, x to the 0 is equal to 1, that's always equal to 1 unless x is 0. And we're not going to work with 0 to the 0, so you don't need to worry about that because that's an undefined quantity. And then we also have this other rule, which I guess we kind of already looked at before, and that is that if you have something to a negative power, again, if you move that from the top to the bottom, the fraction, or vice versa, it changes the sign of the exponent. So here's just a summary of the rules here that we've looked at. There were those sort of 2 other rules that we looked at that we're not going to use very often, right? And mainly that a over b to the negative n was equal to b over a to the n, because if you think about it, that's really just a combination of this rule and that rule together. But here's some more complicated examples. Let's use these rules here to simplify these examples. So I'm going to go through these kind of fast, so if these do get going too fast, you can always rewind and watch it or email me or whatever. But so again, in this case, I'm just going to take the -1 and multiply it times each exponent. So I'll get x to the -2, y to the third. Here I'll get x to the -15, y to the 6th. Here on the bottom I'll get x to the -6, y to the +2. Right? Then my advice would be combine all the stuff on the top and the bottom here first. So there's really nothing to combine on the bottom, so I'm just going to leave that. And then on the top I'll get x to the -17, and then y to the 9th. And then my advice would be, before you start subtracting exponents here and stuff, is make all the exponents positive and make all the exponents positive, because the mistake I see people make is they'll do like -17 minus 6 and get -23 or something like that. But remember, it's this number minus that number, so it would actually be x to the -17 minus a -6, which would give you x to the -17 plus 6, which would be like -11, right? So combining the x's together, you'll get that, and then the y's will just kind of come along for the ride here. You've got y to the 9th over y squared, so that'll give you y to the 7th. And then just remember, when you're done, all the exponents should be positive. So you can use this one of these rules, this last rule. If you have x to the -11th, you can just write that as x to the 11th power, and then you're done, right? You've got 1y raised to a power, 1x raised to a power. All the powers are positive. For this one, again, you get 2 to the -6 times y to the 14th, +14th. You get y to the -4 there, and then that would be all over x to the 4th times y to the 6th, right? Then just simplify. So let's just bring this 2 to the -6 to the bottom. So 2 to the 6th power, I think, is what, 128? And then the y's here, you'll get y to the 10th divided by y to the 6th. That'll give you y to the 4th. And then that x to the 4th will stay on the bottom, and then that's simplified. Okay, here's some other examples, right? So here you'd add the exponents. So common denominator would be 15. So it would be x to the 5 over 15 minus 6 over 15. So that would give you x to the -1/15th. And then remember, you want to make that exponent positive. So you should really rewrite that as 1 over x to the +15th. Right? For this one, again, you'll have a to the 2/3. Then you'll get b to the 4th. Then you'll get a to the 2/9, or sorry, to the 2nd power, right? Because 2/3 times 3 is just 2. And then you'll get b to the -6, right? Then just add exponents together. So a to the 2/3, a to the -2/3 times a squared, right? That'll give you a to the 2 minus 2/3. So that will basically be 1 1/3, which you could write as 4/3. And then you get b to the -2. And then again, just make sure all your exponents are positive. So you'll have to move that b squared to the bottom there. This one, again, just, for problems like this that look overwhelming, just tackle a little piece at a time here. So this will give you x to the -1/4 times y to the 1st. Then you'll take that times x to the 2/3 times y squared all over x to the -2/3 times y. Right? So then you'll basically get x to the -1/4 plus 2/3, and then plus another 2/3, because it's in the bottom, you got to subtract the exponent there, and then that'll be over or times y squared, right? So the hard part is figuring out the exponent on the x's, right? You'll get -1/4 plus 4/3 times y squared. Common denominator there is going to be 12, so you'll get x to the -3/12, and that will be plus 16 times y squared. So you'll get x to the 13/12 times y squared for that one. Now, we can also use the laws of exponents to simplify radicals, because if you think about it, for example, if you write this as a fractional exponent, this is really just 36 times x to the 4th times y to the 6th raised to the 1/2 power. So again, you can just take this and apply that to each thing separately. So square root of 36 is just 6. 4 times 1/2 is just x to the squared, and then 1/2 of 6 is just 3. So you can do it that way. Now we'll see in the next section that there are other ways to do this. There are laws for radicals where you can actually break this down into, if you're multiplying, you can just take the square root of each thing separately, right? If you think about it, it will give you the same answer, but we're going to talk more about that in the next chapter. For this one, again, you take the cube root of the top, which would be 2. Cube root of this would just be 3, right? 5th root of y to the 5th, again, you could just think of that as y to the 5th, or just take 25 and divide by 5. Right? For this, again, this last one would be 2 times a cubed times b squared raised to the 1/2 power times 2 times a b to the 4th raised to the 1/2 power. So you'd get a square root of 2 times a to the 3/2 times b times another square root of 2 times a to the 1/2 b squared. So square root of 2 times the square root of 2 is just 2. Here, if you add the exponents, you'll get a to the 4/2, which will give you a squared. And then b times b squared is just b cubed. Okay, so that's what you get for that one. Now, the last part of this section talks about factoring expressions with rational exponents. And they'll usually tell you what to factor out in these problems. Sometimes you'll have to figure it out on your own. But in general, you factor out the lowest power that you have. So if you compare the powers here and here, right, 1/4 is smaller than 5/4, so that would be the one you'd want to factor out. So again, the idea here is, you can pull an x to the 1/4 out of this term, and then you have to kind of think about, well, what would I have to have here so that when I subtract 1/4 from it, I get 5/4. So you can just do that here, and that would give you x to the 4/4, which is just 1, so you'll get that as your answer. Okay. Here's some other examples. So here you're pulling out a to the 1/3, so that will leave you with an a left over. And here you pull out an a to the 1/3, that'll give you that. And then just simplify what you have in here, right? 2a plus 8a is going to be 14a, and then you'll get -12 there. And then you can also pull out a common factor of a 2, because 2 goes into both 14 and 12. So make sure you factor that as far as you can. Here's some other examples. Now in this case, again, I'm not going to tell you what to factor out, but again, it's pretty easy to determine, right? Just pull out the lowest power here. So pull out x to the 1/3. So if you think about it, right, what would you have to have here so that when you add that to that, you get that, right? Because you're remember, when you multiply, you add exponents. So if you think about it, it would be just 1, right? 3/3, because you add that, you'll get 4/3. And then here you can pull out an x to the 1/3. Well, that's easy. If you pull out the x to the 1/3, you're just left with that. And then just simplify that as much as you can. You've got x to the 1/3. Then you'll have, what, 9x plus 12x plus 5. That'll give you x to the 1/3 times, what, 21x plus 5. Now here there's no common factor like 2 to factor out in the last one. That would be your example, right? For this one, just pull out x to the -1/2. So think about what would the power here have to be? Well, it would have to be 1, right? And here, if you pull that out, you'll be left with 4x plus 1. So you'll get x to the -1/2 times 4x plus 4x, which is 8x plus 1. Okay, and that would be your answer. Okay. So hopefully that gives you guys an idea of what to do with that section. Again, as usual, if you have questions, just let me know.